Okay, so let's start with the new topic, that is multiplication algorithm for sign number, and the sign number is represented in sign magnitude form. Previously we have seen addition and subtraction for sign numbers, and those numbers are represented in sign magnitude, and then we have seen another method to perform addition and subtraction of sign number using 2's complement form when number is represented in 2's complement form, right? So that thing we have seen. Now we'll perform multiplication algorithm, or we'll see multiplication algorithm for sign numbers, and the sign numbers are represented in sign magnitude form. Now if these are the number, suppose 23, 19, and assume the sign is plus, right? So 23 it is 10111, and 19 it's 10011, 16 plus 3. Okay, so this is multiplicand and this is multiplier. We want to perform multiplication of these two numbers. We take sign differently for this. The sign is for this number 0, for this number 0. Okay, now next, how we'll perform multiplication. So if we have like a pen and paper, then it's very simple, right? What you need to do, just take the least significant bit of multiplier, right? If it is 1, directly copy this multiplicand, right? Then next, check the next bit. If it is 1, okay, before that you need to shift 1, you need to shift 1, then it's 1 again, 1011, so copy it 1011, and you need to add it. Next, shift 2, 1 2, then it's a 0, so you can directly write 0, because if you multiply this with 0 it will give you 0, right? So addition with 0. Then next, shift 3, it's a 0, multiply it, you get 0. Then next, shift 4, multiply 1, so 10111, and this will be your 0. So now if you add this, you will get this 110110101, right? And this is your final product. If sign is 00, same, then you can take that sign. So 0 means positive. If it is 1 means negative, you can take it 1, right? Means either sign is 1, your answer is 1. If both are 0, then 0. Okay. Now, so multiplication of two fixed point binary numbers in sign magnitude representation is done by the process of successive shift and add operation that we have seen, right? And the process consists of looking at the successive bits of the multiplier and least significant bit first, right? So we have seen that if the multiplier is with 1, multiplicand is copied down, otherwise zeros are copied down in such cases. Okay, copied number in successive line shifted one position to the left. This is shifted left. Now next will shifted left, next will shifted left, then next will shifted left, right? So one shift, then in that again one shift, in that again one left shift, in again one left shift, likewise, right, to the previous number. And finally numbers are added and then sum. This one is your product, right? But when you go with the hardware, then it's a different thing, right? So there are two methods. in one method you can take consider your sign bit differently, that is your sign magnitude, and other is Booth multiplication algorithm, that we'll see in the next lecture. Okay. So this is the hardware implementation of it. This is the same thing that we have seen in addition and subtraction of sign magnitude, of sign number represented in sign magnitude. The difference is there are two more register. One is sequence counter and another is this Q register. Okay. So multiplication process will slightly change, right, when you implement in using hardware. So first, instead of providing register to store and add simultaneously, right, as many numbers are there in bits in multiplier, what it does, it provide an adder for the summation of two number. This adder and successfully accumulate the partial product. This summation, it's a partial product, means this thing is a partial product, means not exact product, but it adds something in your final result, right? So it will accumulate in your A. The second thing, instead of shifting the multiplicand to the left, right, what we are doing, we are taking 10111 and we are left setting it, the partial product, this thing is shifted right, right, we'll see with the example. So instead of shifting multiplicand to the left, let's do the partial product shift right. Okay. And that will leave the partial product and the multiplicand in the required relation position. So at the end you will get the proper product. And third is when the corresponding bit of the multiplier is 0. In these two situations, there is no need to add all the zeros. This is not required, right, to add this 0. Okay. So it's not required and it will not alter any value, that's why it's not required. Okay. So this is the hardware for multiplication. Now B register, A register, Q register, and this is the sequence counter. This is also register. These are the sign of B, BS, sign of A, AS, sign of Q, QS, and QN. It shows the least significant bit. This is shows least significant bit. Okay. The sequence counter, or let's take Q. What is Q for? Q stores your multiplier. So your multiplier is in Q. Okay. Your B stores multiplicand. Right? B stores multiplicand. And this A stores your partial product. Okay. So adder will take this partial product and your multiplicand, perform some addition, and then back to A. Okay. There is some E associated with this, and you can see there is some line to right hand side. So this shows the right shift. This shows the right shift. Okay. Now your sequence counter. Okay, it's set to the number equal to the number of bits in the multiplier. So in previous case, multiplier, how many bits are there? 1 0 0 1 1, right? So 5. So your sequence counter set to 5, that is 1 0 1. One thing you need to remember is as this operands like 2319, but actually it is plus 23 plus 19. So with this one sign bit is also associated. So when and these operands are stored in memory. So when you get this operand, right, you will get that operand with sign, means one more bit with this, right? But when we initialize this sequence counter, we don't consider the sign. We just consider this value. Okay. So sometimes you will find that your sequence counter value is initialized as n minus 1, right? N is number of bits when you get that number from memory. So in this case, if I want to say that this multiplier brought from memory, then n is 6 because one bit for sign. Okay. So remember that thing, because actual value is 10011. We are dealing with that, right? Right now there is no meaning of sign here. Okay, you can directly check with the sign and you can associate with your product. Okay, so sequence counter, it's also register, so we have stored it 101, and this counter is decremented by 1 after forming each parcel product. Okay, now multiply. So these are the hardware components required for multiplication operation. Okay, now we'll see the flowchart of it and you will understand it, or you will get more insight of this. Okay, now let's go to it. Okay, so this is the flowchart of it. Let's understand that. So multiplicand in B. Okay, so in this multiplicand, okay, multiplier in Q. So multiplier in Q register. Okay, so this is over. Now AS, QS, exclusive or BS. So in B, multiplicand is there, so sign of multiplicand is in BS, multiplier in Q, so sign of multiplier in QS. Okay, so QS exclusive or BS. Okay, so if both the sign are same, then result is positive. If both the sign are different, then result is negative. So this BS exclusive or with BS and QS will give you this AS. That's it. No any further modification is required in this AS. You can directly decide, because in multiplication, positive, 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 negative, negative, the result will be positive sign. Plus, minus, or minus, plus. If these are the sign of numbers, then in that case it will be minus, minus, right? So that we can easily decide. Now next is QS, sign of multiplier. Sign of multiplier. Okay, not that much important now. Okay, then A is all 0. A is all 0. Then E is all set to 0. E is all set to 0. Now in A, how many bits are required? અહીંયા 0 લખ્યું છે, પણ એમાં કેટલા બીટ જોશે, right? So in A, as it is partial product with your multiplicand, so multiplicand માં જેટલા બીટ છે, that bit, okay, એ તમે અહીંયા લખી શકો. સામા? A માં. So A is 0, but how many 0? It depends on number of bits in multiplicand B, right? So in B, 1 0 1 1 1, so 5, right? 5 bits, so 5 0 you can put. because your multiplier is in Q, and ultimately what is your result? Your result is this, A and QA at the end. So Q is multiplier, A is 0, right, and number of bits is that is in multiplicand. Now this will form your result. This will form your result. આનાથી ઉપર તમારી વેલ્યુ નહીં જઈ શકે મલ્ટીપ્લાયરની, right? Because when you multiply, it will increase the number of bits. See this example, 5 bits, 5 bits, and the result is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it will not go beyond 10. Okay. Now next is SC, your sequence counter. Now in your sequence counter, see this n minus 1. Why? Because of this reason that I have told you. The operand are fetched from memory and the sign is with that operand. So we are not using that sign when we initialize the sequence counter. That's why it's n minus 1. But if it is directly given that your multiplier is 1 0 1 1 1, right, it is like this, multiply is 1 0 0 1 1, then don't do n minus 1 because it's specified that 1 0 0 1 1 without sign, right? So directly take n. So remember that thing. Now what next? Observe the qn. Observe the qn. So let's put this your multiplier. So in multiplier, what is in your multiplier? Multiplier is 1 0 0 1 1. A is 1 2 3 4 5. Okay, multiplicand is 1 0 1 1 1. Sequence counter 1 0 1. BS, sign of this, let's take the positive number. So BS is 0, QS is 0 multiplier. So if you perform exclusive OR, it will give you 0. So this is done. So we have performed this thing. Now we'll check QN. What is QN? What is QN? QN is this least significant bit of Q register. So in Q register, what we have? 1 0 0 1 1. So this is QN. This is QN. So QN is 1. Okay. So QN is 1. So what we need to do? Perform A plus B and store the result in EA. So we need to perform A plus B. Okay. So perform A plus B. What is in A? A is 0 0 0 0 0. What is in B? 1 0 1 1 1. If you add it, right, the result is 1 0 1 1 1, and again you need to store in EA. So now this will be 1 0 1 1 1. Okay. Okay, we have done this. The next is shift right operation of EAQ. Shift right operation of EAQ. So this flip-flop and these two register we need to shift right. Okay. So let's do it. In E, what is in E? It's a 0. Here E is 0. So this is 0. Now perform shift right operation. So when you perform shift right operation, what happened? This least significant bit discard થશે કારણ કે આ બહાર જતો રહેશે રજિસ્ટરની. So now 1 0 0 1. Shift right. This is the empty position. So this will move to that empty position. 1. Okay. And now 1 is moved to this. Shift right 1 bit. Shift right 1 bit. Okay. So we are shifting right but with 1 bit. So here 1 1 0 1. આ 1 ક્યાં ગયો? અહીંયા most significant bit position of multiplier. Okay. Now next, this is empty position, so what we need to move? E 0, and here it's empty, so you can see if it is empty, just put 0. Put 0. So after shifting, performing shift right operation EAQ, what is the value? 0, 0, 1, 0, 1, 1 and 1, 1, 0, 1. Okay. Shift right one bit, તો least significant bit નીકળી જશે અને આ બધું થશે, રાઈટ. સો અહીંયા QN થી આપણે શું કર્યું? least significant bit check કર્યું. If it is 1, then add. If it is 0, no need to add. Qn is 1, then add. Qn is 0, don't add, right? That is not required to add 0, so we are omitting it. Okay, this step over. So I was to take it. Next is SC is equal to SC minus 1, so we need to decrement the count. So this count we need to decrement, so now count will be 1, 0, 0. Okay, so we have done this. Now check the sequence counter. Is it 0 or not equal to 0? If it is 0, then you need to end, and your product is in AQ. Your product is in AQ and sign is in AS. Okay, if not equal to 0, then repeat the steps. Take the least significant bit, check the least significant bit. If it is 1, add it. Otherwise, if it is 0, shift right operation, decrement the counter, sequence counter, and then again check SC. So we have performed till this thing. આટલી વસ્તુ મેં તમને હમણાં બતાવી અહીંયા જે આપણે કરી, right? So next, after performing this, so you see 100 is our sequence counter. So 100 is our sequence counter. What is our Q? Q is this one, 11001. So 11001. What is A? A is 01011. 01011. And what is E? E is 0. So till this thing we have performed. Now again you need to check what? You need to check Qn. Okay, because this sequence counter is not equal to 0, so we need to continue. So again check Qn. What is Qn? Qn is this one. This last column is your Qn, your least significant bit. So it's a 1. So if it is 1, add B. So you need to add B. So in this A, we are adding B. And when we add B, the result will be stored in EA. So now A is 01011 plus B 10111. When we add it, it will generate this, and in E it will generate 1. E માં શું આવે? 1. Right? So E and your A. Okay. So we have added. Now next step is shift right EAQ. So now perform the shift right operation. Okay. આને કંઈ નથી કરવાનું. Shift right operation of EAQ. Shift right operation of E, A and Q. So when you perform shift right operation, so this will be discarded. This one 0, 0, 0, 0, 1, 1, and this is empty. So bought this one A. Here 1, 0, 0, 0. This is empty. So what we need to bring? E. So E is 1. So 1 and E. E is empty. So in E, what will come? 0. So 0 will be there. Okay, so shift right operation is over. After shift right, decrement the counter. So we are decrement the counter 0, 1, 1, 3. Okay, then check the counter. Is it 0? No. Again, continue. Again, continue. Okay, now what is the value of Qn now? So when you perform this shift, after that the Qn is 0. Qn is 0. So when Qn is 0, what do you need to do? You need to just say, perform the shift of EAQ. No need to perform the addition operation. Okay, so just perform the shift right of EAQ. So when you perform shift right, this will be discarded. And again, the same thing. Empty about this one. Empty. So now about the E. E is 0. So 0. Now E is empty. So as you can see, 0. So just put 0. Okay. Again, decrement the count, sequence count 0, 1, 0. Right. Then it's 0. Again Qn. Again perform the shift right operation. When you perform shift right operation, you will get this. After that, you will check Qn. Qn is 1. Right. Qn is 1. So when Qn is 1, you need to add E A plus B. So add B in A. So A is 0, 0, 1, 0, 0. Add B. What you will get? 1, 1, 0, 1, 1. E is 0 because there is no carry. So E is 0 also. Then perform shift right of EAQ. આ ત્રણનું જ EAQ. So when you perform shift right? Same thing. આજે હશે નીકળી જશે. Okay. So 1, 0, 1, 0, 1. આ નીકળી જશે. So 1, 1, sorry, 0, 1, 0, empty. So here you will get 1, 1, 0, 1, 1, empty, E. And E is 0. What is your result? Result is, and then you will decrement the count. So 0, 0, 1, you will decrement 0, 0, 0. SC is 0 now, so end. So when you end it, right, the result is this. A and Q. A and Q. This is not in your result E. Right? So AS will carry your sign and AQ combine will give you the product. Right? So if you carefully observe that અહીંયાથી જે multiplicand હતો, right, multiplicand. So we were taking that multiplicand 1, 1, 0, 0, 1. Sorry, multiplier. This one. So 1, 1, 0, 0, 1. We were taking that multiplier as a least significant bit, right? And we are using the other bits for storing the partial product, right? જ્યાં partial product આવતી હતી એ બધી store થતી જતી હતી, right? So initially we'll get this one, then we are shifting right. So this way we are forming our product. અહીંયા જો તમે partial product જે છે પહેલા શું આવ્યું 1011, right? Then it is shifted. So this way ultimately we get our product in AQ. Okay, now this is not a multiplier. Now Q માં હવે multiplier નથી. Initially there is multiplier, but it's not a multiplier. AQ combinedly, it's now product of B and Q જે initially હતા. Okay, so this way you can perform the multiplication of two sign number, which is represented in sign magnitude form. Any doubt in this? Any doubt in this?
No, sir.
Getting this thing?
Yes,
યસ
sir.
સર હમણાં સમજમાં આવી ગયું છે. બસ એક બે એક્ઝામ્પલ મેં કરી લેશું તો થઈ જશે સર, સમજાઈ જશે.
Yes. So for this example, as we said, that you require practice. You require practice. Otherwise, what will happen? That you know the concept, like the flowchart is given, and now you getting the things. કે કઈ રીતે થાય છે, now you know. But if you don't practice, then when in your exam such example asked, at that time the doubt is generated, right? અને એ વખતે ડાઉટ સોલ્વ કરવા માટે કોઈ નહીં હોય. એન્ડ ઇફ યુ પ્રેક્ટિસ ઇટ, તમારી સ્પીડ એમાં વધશે અને તમે ફટાફટ એક્ઝામ્પલ સોલ્વ કરી શકશો. અધરવાઇઝ એ વખતે સમજવામાં અને એમાં પછી ટાઈમ જશે અને મિસ્ટેક, કારણ કે આમાં એક બીટ ચેન્જ થઈ જાય, રિઝલ્ટ ઇઝ રોંગ, રાઈટ? તો એ ના ચાલે. If such example is asked, what we'll check first? We will check for product first. Is it correct? Right? If it is not correct, no need to check this thing. Right? If this is the correct, then we'll check these registers. કે એમાં પાછી મિસ્ટેક નથી ને, કે રિઝલ્ટ સાચું આવી ગયું છે પણ અહીંયા મિસ્ટેક નથી ને, that will check. Okay? Now suppose if you are adding zeros in multiplier, suppose if these are now in 5 bits, suppose total 8 bits for operand, 8 bits for operand, so 1 bit for sign and 7 for that value. Okay, so in such case, if I need to represent 19, then sign is 0, and for 19 1 0 0 1 1, right? 5 bits. For remaining 2 bits 0 0. આવું થશે. તો આ કેસમાં શું થશે? This will not do anything, 0 0, right? Steps અમુક વધારશે, right? Now the your sequence counter is 7 instead of 5. અને જે બે સ્ટેપ્સ હશે એ શું થશે? આના જેવા. Just you need to perform shift right operation. Okay. So this is the flowchart and example for multiplication operation. So in next lecture we'll see this Booth algorithm. Okay, and most of the time this Booth algorithm that is used in your system multiplication purpose, right? You can see less hardwares, okay, and easy operations, right? It reduces some of the operations, number of addition and all. So we'll see the Booth algorithm in next lecture, and if you have any doubt you can ask me. Okay then, so you can leave the meeting now, and in next lecture we will start with Booth algorithm. Thank you for joining.
થેન્ક યુ સર.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.